Welcome back everyone to another video in our Fundamentals of Structural Engineering course. In this video, we are going to learn about structural design of RC columns under normal forces. Same like we have said in beams, this is the governing formula for the design of RC columns under normal forces, which is phi Pn has to be bigger than or equals to P ultimate, where P ultimate is the factored normal force, while Pn is the nominal strength of the column itself under normal forces, of course, and phi is the reduction factor or the resistance factor in case of compression controlled sections, which equals 0.65. So rho, which is the reinforcement of the steel, here this is an important information you need to know, which the rho, which is the percentage of the steel area steel over area gross, the reinforcement area over the total area of the RC section, has to be more than 1% and less than 8%. So this is the minimum reinforcement in column, and this is the maximum reinforcement in column as per code requirements. Even if you need less than 1%, you need to keep 1% as minimum, and if the concrete column needs more than 8%, this means that you need to increase the dimension of your RC column, and in this case the percentage of the steel, it will be lower. This is the governing formula to calculate the nominal force of the column, which is phi Pn equals 0.85 multiplied by 0.85 FC prime multiplied by area net, which is area gross minus area steel, plus area steel multiplied by F yield. So this term here is for the stress component or the strength component of the concrete, and this term here is for the strength component of the steel. So let's have an example on this. Here we have a short square tight column, has a minimum area of reinforcing steel of 3.24 inches square. This is the area steel, and the gross area of 18 inches square. This is the area gross. The compressive strength of the concrete is 4000 psi. This is the FC prime, and the yield strength of the concrete is 60,000 psi. This is the F yield. What is the most nearly the design axial compressive load capacity? So we want to calculate, this is the design axial compressive load capacity, so we need to calculate the phi Pn. We know that phi equals 0.65 for compression members, and we know that the equation for phi Pn equals 0.85 multiplied by 0.85 FC prime multiplied by area gross minus area steel, all plus area steel multiplied by F yield. We have all of these data now, so phi Pn equals 0.8 multiplied by 0.65 multiplied by 0.85 multiplied by 4000 multiplied by 18 minus 3.24, which is the area gross minus area steel, plus 3.24 multiplied by 60,000. All of this is going to be divided by 1000 because instead of PSI we want it to be per KSI, because we want it, instead of being on pound, we want it per kips, which is 1000 of a pound, because here all of the choices are per kips. So solving this equation, you find that phi Pn equals 127 kips. So the closest answer, which is the first option here, which is 130 kips. So this is it for our video today. See you in our next video. Thank you.